So we are going to cover rational exponents and radical expressions. So the rational exponents have multiple rules that you need to remember from 8th grade and 9th grade. And for that, you need to know the power rule, which is when you have two numbers that have the same base and you're multiplying, you're going to add the exponents. The quotient rule is whenever you are dividing two numbers with the same base, you're going to subtract the exponents. The power rule is whenever you have a number with a base raised to an exponent, and that's raised to an exponent, the only thing that you're going to do is multiply the exponents together. The power of a product rule is whenever you have the same exponent but different bases, you're able to multiply the bases and keep the exponent. We don't do anything to the exponent. The same applies to division. Same exponent, different bases, divide the number. So that's how you can simplify. Anything to the 0 power is always going to be 1. And whenever you have a negative exponent, so in this case 5 to the negative 8, that's going to be the same as 1 over 5 to the 8th power. The only portion that we're going to be adding in this case is going to be a fractional exponent. A fractional exponent is whenever you have a number as your base and you have an exponent that is a fraction, you're able to rewrite it as a root. The basic exponent notation, and as we have mentioned before, is this number is going to be your base and the exponent is going to be the smaller number on the expression. Whenever we have a rational exponent notation, we know that the numerator is going to be the exponent, so the number of times we're multiplying that number, but the denominator is actually going to be your root. Sometimes you're going to see that your exponent may be a number like 1. So in this case, it means that we're not going to be multiplying 5 multiple times, but we know that this is going to be your root. When you have a radical notation, though, we're going to call the number outside your index. This is going to be the radical symbol. Your base is called the radicand, and then we have our exponent. So to convert between exponent notation to radicand, we're going to get the base. The base right here is going to be your radicand. Your root is going to be your index, and the exponent is going to stay the same. You're able to write this in different forms, and everything is going to depend on how you're solving the problem or what do you need this for. This is another way that we can represent the same problem, but now instead of putting the exponent right next to the 5, we can actually put it outside. It is exactly the same thing though. So for the first example, we're going to convert to an exponential notation. So that means that the radicand, so the 3, is going to be the base. And then we're going to get a fraction. The exponent stays the same, so that's going to be 5. And then our root is going to be your index, so that's going to be 4.